Hello. Good afternoon, sir. Dr. Indra Mitra, sir. Hello. 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 Good afternoon, Dr. Indra Mitra. Hello.
Good afternoon.
Yeah. Good afternoon. So now,
We start at 3.
yeah, we'll start at 3. So the ended early, so we have given a break.
Oh, okay. Okay. So
Okay.
let's just wait
Oh,
until.
yeah. Yeah. Okay.
Okay. Okay. Thank you.
Yeah. Sushma, can we start the session?
Yes, ma'am. Shall I start, ma'am?
One, uh, uh, 1 minute. Okay. People are joining, so. So, sir, can we start, sir, now? Hello?
Yeah.
Yeah. Okay. Welcome you, sir, for this afternoon session, the last lecture of this webinar. And then, Ms. Sushma, can you introduce the speaker?
Yes, ma'am. Good afternoon, sir.
Good afternoon.
Dr. Indra Mitra, Director at Cambi, Europe, India. Dr. Indra Mitra is one of the leading wastewater technologists in the country for the design of operation of biological wastewater treatment. He received his BTech degree from IIT Kharagpur and has done his MS, PhD, and MBA from USA. He has been providing wastewater consulting expert services to US and India. He is a registered professional engineer of State of Virginia, USA, with 22 years of domestic and international water and wastewater experience. He has authored several books and papers and is a member advisor to several leading water and wastewater associations and organizations. We cordially invite you, sir. I have already made you the co-host. You can start your presentation now. Thank you.
Thank you. Thank you for the introduction, and thank you everybody for tuning in to listen to my presentation. I will just share my presentation. Can you see it? Can you see my presentation?
Yes, sir.
Yes, sir.
It's visible.
Okay. So I will just reduce this. Okay. I think this would be. Let's see. Okay, today's topic that I will be talking on today is circular economy, sludge to fertilizer and energy. And I will be mainly talking of Cambi thermal hydrolysis process. I work in this company as a director technical and project development. Okay, next page down. Why it is not going down? Okay, today's agenda, I'll talk about Cambi. Then I'll start with a brief introduction of my presentation. Then we'll talk about Cambi thermal hydrolysis process, and we'll talk about what are the benefits of Cambi, and we'll compare the Cambi technology with other technologies in the same field. We'll talk about anaerobic co-digestion, sludge centers, and the services we provide, and the references we have, and the key takeaways from this presentation. So with that, I'll start my presentation about Cambi. Okay. Wait, it's not going down. Okay, Cambi is a world leader in sludge management. I think people are still coming in. We are #1 in the field for producing Class A biosolids. What is happening? We deliver innovative solutions that enable water utilities to manage sewage sludge from wastewater treatment plants. Our core technology is thermal hydrolysis. Our work contributes to achieving 8 of the 17 United Nations Sustainable Development Goals. We are present all over the world, mostly in Europe and UK. We have a lot of plants in UK. We process about 50% of sludge of UK. We have plants in US, plants in China, Singapore, and we are planning to come up with plants in India. We won several awards, and top 3 awards are we have been adjudged as the top 3 technologies of the decade in the wastewater space. We won the WEX Global Award in 2020, and we have been selected by ETV program by Namami Gange in India. Our headquarters is in Asker, Norway, and our workshop is in UK, and we have about 7 offices worldwide. These are mainly the offices: Norway, UK, Spain, France, USA, China, Singapore, and South Korea. We are going to set up one in India. Besides, Cambi also has another company, a sister company, which was previously known as Hearst, and is now renamed as Grondwachst. It works in converting waste into fertilizer, and it's Norway's largest soil producer, and it's in headquartered in Grimstad in Norway. Okay. As you know, sludge treatment is becoming increasingly important as its production is growing, and growth of sludge production in sewage sludge I'm talking about is mainly due to increasing global population, which according to the United Nations increases by about 0.8 to 0.8 billion every 10 years. And as you can see, over the years, the population in the urban areas is increasing at an alarming rate. So this provides, a lot of pressure on the wastewater infrastructure in the cities, and so we have to build a lot of wastewater treatment and also water treatment, of course. And the sludge from the wastewater treatment needs to be processed in the right way. So we can recover all the resources from the sludge. So you will see a tremendous growth in the sludge sector. And so basically, let me go back. The urbanization, there is a trend in increasing urbanization. In 2007 was the first time more people lived in urbanized areas than rural areas. By 2050, we estimate about 2/3 of the population will be living in cities, and increasing expenditure in wastewater treatment infrastructure, especially in in Asia and developing world. So next, we're going to talk. Can everybody hear me? Is the slides clear? Can you hear me?
Yeah, yes, sir.
And you can see the slides also. No problem.
Yes, slides are also.
Okay, just let me know if there is any problem. Okay, so that's about the cities and and the population growth we talked about, and we need, especially in India, we need to gear up and build all the wastewater infrastructure and think about a plan to treat all the sludge more effectively. Another issue that is coming up is the growing focus to reduce climate footprint. And that's where the focus is also on renewable energy. So we are looking forward to it. And as I said before, India is signatory to a Paris Agreement, and is committed to reduce 40% of the and it is 40% of its electricity should come from renewable energy. India has already installed about 35, 36% and installed, and they are at 21%. And the sludge.
Hello, sir. Sir, can you just loudly, because some of the participants are claiming that it's the volume is very low.
Okay. Can you hear me now? Is this okay?
So,
hello.
madam, is it okay now?
Can you hear me?
Hello.
Yeah.
Sir, hello. Is it okay now? Hello.
I don't know. Probably there is some problem with my system, but it is very low.
Okay.
So,
okay.
given ear voices.
Anybody else having the problem? That's just let me know, and if there are issues, we need to address it. Okay, so now there is a growing focus, as I was talking about. India has already installed 35% reduction in renewable energy. India is supposed to cut down by greenhouse renewable energy fraction in the electricity production by 2030. India has committed to do 40%, and India has already installed about 35%. And it's operating at around 21%. So we are going good on that, but India has self-imposed some internal deadlines, and that is by 2027, India wants to have 57% energy, renewable energy in electricity. That's a ambitious thing, but it is also not impossible. The rate we are going. So we are doing good on that part. And sludge, as you know, is a huge resource there from which we can recover energy, and that will change the entire scenario, because sludge is generated all across the cities, all across India, even in villages, and so you can generate the sludge at that place, and you don't really have to transport it to and we'll talk about that. Another growing focus is to reduce climate footprint. We are currently observing worsening impacts of climate change. We have witnessed, and in fact, it's still happening in California, wildfires we've seen in Australia. In California, there's a lot of wildfires and worsening storms and droughts year on year, hottest temperatures, and so between these events and the anthropologic release of carbon dioxide into the atmosphere, there is a relationship, but fortunately, our governments are responding to this growing crisis by making attempts to slow these impacts in a variety of ways, including production of renewable energy, encouraging use of recycling, minimizing use of landfills. The water and sludge industry plays an important role in abatement of carbon dioxide production. The water industry is one of the heaviest users of energy of any industry. In a study in the UK, the water industry used approximately 3% of the nation's energy and was responsible for a similar figure relating to carbon footprint. So there is a vast opportunity there to reduce carbon footprint if we focus on the water and wastewater industry. There is a lot of nutrients in wastewater and sludge. This could be used to offset the use of fossil fuel rich fertilizers. These fertilizers typically generate a carbon footprint of approximately 10 kg of CO2 per kilo of nitrogen or phosphorus, and use over 5% of the world's natural gas. Therefore, use of a safe biosolids product can reduce the carbon impact. by anaerobic digestion, it is possible to turn waste in the wastewater into biogas, a methane enriched gas, which can be used to generate electricity and heat in an engine, or processed further where it can be used to displace natural gas or even used as a fuel in vehicles. So enhancing anaerobic digestion results in greater production of biogas than standard anaerobic digestion process. As most of you know, in an anaerobic digestion process, we convert sludge or organic materials into biogas, which is nothing but methane, about 65% methane and 35% carbon dioxide, and you can use that methane as a source of CNG or even produce electricity. But our process, basically what we call is an advanced anaerobic process, where we put in thermal hydrolysis process in addition to the digester to increase the biogas production. And there are several benefits which we'll talk in detail. So now the trend of thinking is there is no such thing as waste, only wasted resources. So, you may think there is some waste, but this waste may be used in some way or the other by other people. So, so there is nothing called waste. That is one thing you have to understand. So the concept of circular economy has come in, which is converting waste to wealth. That we have waste, we can convert it into some usable product. One is in the wastewater sector. I'm talking about, there is recycle and reuse of treated wastewater. So you can treat your wastewater to a level where you can recycle and reuse it for different purposes like toilet flushing, gardening, and many other, cooling tower, makeup in the industries, industrial, many plants in India are now sewage treatment plants are treating wastewater and giving it to the industries. Also, I think the power plants are mandated to use recycled wastewater for their water needs. So there is a lot of steps going on in India. Sludge to energy, anaerobic digester is a big thing where we convert the organics or the sludge into biogas, as I said before, and we can recover energy from there. Then sludge to fertilizer, we have so far we have a problem with sludge, and we were either landfilling it or we were not disposing it in the right way. We were giving it to the farmers, which is actually not healthy. I will discuss that in detail a little while. But if we can convert the sludge into fertilizer, then we can sell it. This is where Cambi technology comes in, and it converts your sludge to fertilizer, and at the same time increases the energy production from the sludge in the anaerobic digesters by 20 to 50%. Recovery of phosphorus, the reject water that has a lot of waste in the wastewater. There are technologies to recover phosphorus. As you know, phosphorus is an expensive element, and can be utilized for production, and you can actually sell it. There are many plants doing that, many wastewater treatment plants. And so you can see that the whole wastewater treatment plant has been transformed from a waste to now we are getting resources out of it: water, energy, fertilizer, phosphorus, all these things. So now many plants are renaming their plant, wastewater treatment plant, as water resource recovery facility. And by putting in all these new technologies, new generation of technologies, and there is a huge movement in the world now to go towards circular economy. And as a process also, these technologies reduce greenhouse gas emission. So that is an added advantage that you get. Now, to give you a classic example is Washington, D.C. wastewater treatment plant. It's a It's a 391 MGD. That's about 1200 MLD plant. It is the largest wastewater treatment plant in US, and this is the Camby system that we have supplied. The DC, it is under DC Water is the municipality that handles Washington DC, and they have done extensive studies for over years, evaluating different technologies, involving a lot of universities. Virginia Tech was involved, George Washington University was involved to do a lot of pilot studies. And then ultimately, of all technologies, they selected Camby THP. And the DC Water Program team is reinventing biosolids at this 391 MGD, a Blue Plains Advanced Wastewater Treatment Plant in Washington, DC. And and has installed the first Camby thermal hydrolysis process in North America. And today we have eighth one. We just got plant. We just got the order for that at Washington WSSC in Maryland. And the Blue Plains Biosolids management program included Camby and reduced biosolids quantities by more than half. 50% reduction of your biosolids. It cut the greenhouse gas emissions dramatically. It generated 3 megawatt of clean renewable energy and greatly improved the final sludge product quality. And as a result, they saved millions of dollars annually. And they have Washington DC has saved actually $200 million over a period of 15 years by installing Camby. And also they have started a new company there. The sludge they are now selling, and it's a multi-million-dollar company now. They are selling this sludge from Camby and earning money from it, which we will discuss in detail. Okay, now sludge, as we know, we treat it, but then to what level we need to treat sludge and how to dispose it. It is governed by EPA biosolids rule. And this rule is followed in USA, and many countries are following this rule, and including India, the new tenders that have come in, they follow the biosolids rule. So just to give you an overview, this is applicable this rule is applicable only for sewage treatment plants, and the sludge, as you know, contains a lot of pathogens, like during as you know, we are going through a coronavirus crisis, and all this wastewater from the city, from your houses, from hospitals treating coronavirus flows into your wastewater treatment plant. So this wastewater treatment plants contains pathogens, including coronavirus. And so these pathogens go, separates into your treated water and the sludge. So the sludge, treated water, you treat it by by disinfecting the wastewater. But the sludge creates a huge problem, because just by disinfecting, it doesn't go away. It again come back. It again comes back. So what we need to do, we have to use certain technologies to kill this pathogens. And right now, I will discuss in more detail. We do not treat this adequately, and everybody gets infected. The farmers take the sludge, they get infected, they grow the crops on it, the crops get infected, and also the crops are sold in the market. So people like you and me go and buy buy all these crops, and we also get infected. So that chain needs to be broken. I think Gopi Krishna has raised some hands. Is there any questions regarding that, Gopi?
So he said it. There are no questions from his side.
Okay, there was a raised hand. Okay, no problem. Okay, so sludge contains STPs and presents a health hazard, as I was talking about. So treatment and safe disposal of sludge is required. When we treat sludge and then we use it for a beneficial use, we do not call it sludge anymore. We call it biosolids. Currently in India, there is no regulation for disposal of sludge, and we urgently need one. USA and numerous countries follow EPA biosolids rule for disposal of sludge. It is applicable mainly for STP sludge and septage, this regulation, EPA biosolids regulation. And the biosolids rule establishes criteria for various modes. There are 3 modes of biosolids disposal. One is land application, another is surface disposal, another is incineration. So for each applicate 3 things, each way mode where they establishes criteria, of which land application is the most favorable one. Land application means you basically use it as a fertilizer and recover the values attached with the sludge. Okay, land application preferred because it promotes circular economy. It's recycle and reuse of biosolids. Biosolids is a source of carbon, nitrogen, and phosphorus and other nutrients. So it can be used as a fertilizer. To be land applied, there are 3 criteria. One is the concentration limit for 10 heavy metals. Next second criteria is you have to meet vector reduction, means the volatile solids in your sludge needs to be reduced by 38%. The regulation gives 12 options, but anaerobic digestion is the most commonly used process, where you not only reduce volatile solids more than 38%, but also you generate energy out of it. And then the third criteria, you have to meet pathogen reduction. Based on your level of reduction, then you are called, your biosolid will be called class A or class B. When the biosolid is treated to achieve less than 1000 mpn, most probable number of dry solids per gram of dry solids, or density of Salmonella species bacteria is less than 3 mpn per 4 gram of dry solids, then we call it class A. Otherwise, we call it class B for fecal coliform up to 2 lakhs mpn. Now you can see class A, when it says 1000 mpn, means that the sludge has no pathogens. You have killed all the pathogens. Class B, it says you can have up to 2 lakh pathogens. Means you so that means they are up to 2 lakh fecal coliform, means there will be some pathogens. Fecal coliform is just an indicator organism to measure how much what level of pathogens are present in the sludge. So if you have fecal coliform less than 2 lakh but more than 1000, that means there are possibilities, lot of pathogens are there. So class B sludge, you cannot just put it anywhere. You have to put it in a land where there is no human contact. This is according to the regulation. Means you have to put it in a land for like 6 months to 48 months, depending on the type of crops you grow. That is the requirement according to the regulation. So there is some problem, but class A, you do not have any restriction because you have killed all the pathogens. So class A is considered safe, and you can use it directly in your home. You can sell it in the market like normal pathogens. And all this, there are regulations how to kill pathogens, and the compliance is measured at the point of disposal. That is the land application. This is a sludge treatment scheme that we have. Generally raw sewage comes in, you have preliminary treatment, then primary treatment, biological treatment, and disinfection. This is the one that kills the pathogens and all the bacteria, bad bacteria and everything. before it is discharged. But in the sludge, we cannot just do disinfection. And so the sludge that comes in, first primary sludge and secondary sludge. So first option is we do thickening and dewatering. It is not a treatment, it is just taking out water. So this is about 2-3% of solids comes out from primary clarifiers, and secondary clarifiers of 0.8 to 1% solid comes out, and it goes into the thickener, and they thicken it to around 4 or 5% solid, and then it goes into the dewatering equipment where they further dewater it to about 18 to 20%, 25% solid, depending on the dewatering machine that you are going to use. Okay, so all you are doing is there is no treatment. You are just squeezing out the water and making the volume of sludge to be disposed of reduced. So initially you might have 1% and it is going out at 20% solid, means you have reduced the sludge volume by 95%. So that is the only thing they do it, but they don't do any other treatment. So, but according to EPA rule, you cannot dispose this sludge as fertilizer, although it contains nitrogen, carbon, nitrogen, phosphorus. The reason being there is no treatment. So it is a quality which is less than class B. Then the next option, this is in India, this is more like 80-90% or 90% of the wastewater treatment plant have this scheme, option 1. Okay, now some facilities like in Delhi and Bangalore, they are producing class B solids. How they are doing it? They just put in a digester. So this is a typical scheme. You have the thickener, you have the dewatering, and in between them you have a digester. So by putting in a digester, you get rid of the 38% volatile solids, you generate biogas, and you further reduce the volume of the sludge to be disposed, because there will be around 45 to 50% destruction of volatile solids. So this is option 2. This will produce class B, means it will produce class B, which is a treated sludge, but it will still contain some pathogens. So disposal, according to EPA rule, has to be in a way that there is no human contact for 6 months to 48 months, depending on the crop where you want to use it as a fertilizer. Okay. Option 3 is what we call producing class A. This will produce class A, and how does it do it? Is between thickener and digester, you put in a THP system. So this is another treatment you have to do. So class A means you do not have any pathogens. It is safe to use anywhere you want, including your home lawns and gardens, parks, everywhere. So that is a better quality than class B. And as you see, as you increase the sludge quality, the number of treatment systems increases. So from no.
Hello, sir. Any problem? Is there any problem? Hello.
Yeah, I think somebody muted me. Okay. Now you can hear me, right? Hello.
I can hear. Yeah, we can hear you.
Okay. So now what happens is, as you increase the quality of your sludge, the more treatment is required. So first, you do not have any treatment, just dewatering. Second, your sludge cannot be actually used as a fertilizer because you have not taken care of the pathogens. And then you put in a digester, so you have taken care of the pathogens up to a limit. So the rest is done by disposal in a place where there is restriction of people coming in, so there is no human contact. And the third one is there is no restriction, and by that you have to put in a CAMBI THP process between thickener and digester, and this is what the process is. We'll discuss this in detail. So now, what is CAMBI thermal hydrolysis process? It is nothing but a pressure cooker. Okay, the sludge, as you know, we get it, it is very hard to degrade. So we subject that sludge to 160 degrees centigrade at 6 bar pressure. By doing that, we get certain advantages, and which we will discuss. So it's a two-stage process where we high pressure boil of sludge, like you have Hawkins pressure cooker. You just cook it, it's a pressure cooker in steel tanks. We cook it with steam at 160 degree centigrade and 6 bar pressure. And after doing that, then we have another unit where we just allow the sludge to suddenly we expose the sludge at 6 bar pressure. Suddenly we expose it to atmosphere. This process is called steam explosion. Sudden exposure from pressure has dropped from 6 bar to 1 bar. Sudden exposure to atmospheric pressure. Now this creates a lot of pressure in the bacterial cells, which ruptures the cell wall. As you know, cell wall is very hard to degrade and it doesn't come out. So the cell wall ruptures, and the cytoplasm and all the degradable material, which is very degradable, which was enclosed within the cell wall, comes out and makes the sludge very much biodegradable. Plus, in addition to that, all bacterial cells has EPAs, extra polymer substances, and which retains lot of water along with it. Now, because of this extra polymer structure is totally destroyed, and the water comes out, and so as a result, you will see that dewatering is much more easy with THP sludge, and we will discuss that in detail. So this combined action of high pressure boiling and decompression leads to three important things. One is sterilizes the sludge, means it kills all the bacteria. It kills everything. It kills all good and bad bacteria. So if you go to a hospital and if you have to do surgery, all your equipment are sterilized, and that sterilization takes place around 122 degrees centigrade for 30 minutes, or for few minutes at 135 degrees, 32 degrees centigrade. Here we are doing it at 160 degrees centigrade, and that too at 6 bar pressure. So we are killing all the bacteria and virus and everything. So so that's why the product from our the sludge product from our system is very, very sustainable and stable and 100% compliance. Second thing, it changes the rheology of the sludge and its properties, and we will see that. And the third thing, it makes the sludge obviously more biodegradable. So you have a sludge, subjected to 160 degrees centigrade and at 6 bar pressure, and because of that, you will see that the sludge becomes very biodegradable. It's like if you put in an apple or a mango before, now instead of that, you're putting it apple and mango juice. So it is much easy to degrade. Okay. So this is a Cambi thermal hydrolysis process schematic. You will see this is the digester, and you will have sludge coming in. First you dewater it, and then you send it to the Cambi system, which has three parts: pulper, reactor, and the flash tank. And pulper is basically a preheating tank where the sludge comes in, and the steam from this is used to preheat the sludge. And in the reactor, we subject it to 160 degrees centigrade at 6 bar pressure with steam generated in the boiler. And in the flash tank, we suddenly expose the sludge from 6 bar to 1 bar pressure. And then it goes into this digester, and then you have a final dewatering equipment as usual you have in a normal conventional system, and then it is struck down. This is another way of explaining, showing this is your primary sludge that is coming in. This is your secondary sludge that comes in. You dewater it, then you store it if required. Some places we store it in a sludge silo. Then it goes into the THP system. You have the pulper. Then this is the reactor, and this is a flush tank. And since this is at 160 degrees centigrade and this one is at 37 to 40 degrees centigrade, which is the digester, you need to actually cool down the sludge to maintain this temperature. And and then you dewater it and it goes out, and the steam is injected from the steam boiler, and this steam that is generated from the excess biogas that it produces within the digester. So it does not require any additional energy for generation of steam. That is the beauty of the process. In fact, once you install it, you get a net production of biogas, which I'll explain. So this is the schematic pre-dewatering. This is the thermal hydrolysis process that we put in, and we put it into the digester. And as you can see, this digester will generate biogas. If you put in this, then a conventional digester will generate 20 to 50% extra biogas, of which only 5 to 15% will be used in the steam boiler, and the rest will go into CHP. The steam is 90% of the steam is generated from the flue gas that comes out from the CHP. It's only the 10% of the steam is generated from this biogas. So you have a system, this is a flue gas. Anyway, you would have thrown it away. Now you are generating steam out of it. So the steam generation, there is no extra energy required. That's the beauty of the process. So you are producing 20 to 50%, maybe 30-35% biogas, of which 10% is used for steam. So you produce a net of around 20% extra biogas. So that by putting in a CHP, in addition to other advantages which I will discuss. This is the equipment that is going. You need a sludge dewatering unit. You need the THP system. This is the THP. You need a boiler, steam boiler, and these are the coolers, because the temperature needs to be reduced coming out, because the temperature is coming out very high out of the THP, and then it needs to go into the digester. So this is a video of how system works. So you see the sludge is coming out. We dewater it to 16 to 18% in the pulp vessel. Here the sludge is heated with steam, and then it goes into 4 tanks. It can be 3 or 4. And these are all operated in batch, because that is required by the regulation, that it has to be batch process, because because some of the particles, if it is a continuous process, then as you know, in non-ideal situations, which we will encounter in real life, that some of the particles may not stay for the time equal to the detention time, and it may escape. So this has to be operated in batch process to ensure that it is there for 20 to 30 minutes in this tank. So these tanks, they hold it for 20 to 30 minutes in the reactor, and then the sludge goes out. So feeding is continuous, exit is continuous, but the reactors are operated on a batch mode. Now this is going into the flash tank, and suddenly this sludge is exposed to atmospheric pressure. This is what we call steam explosion. Now, because of that, all the cell walls and all the EPS gets destroyed, and it improves the performance of digester tremendously. And the steam that is and the steam that is there, the steam that is generated is recycled back into the pulper to preheat the pulper. So we are capturing the heat to heat this pulper, and all the things are then collected and sent to the digester. So this is the steam that is going in from the bottom, and it goes in to the reactors. Okay. We supply in different modular forms. We have modular systems. So basically, we have three B2, B6, and B12 model, and these are of different sizes depending on how much of sludge you want, and so depending on your facility. So if your dry solids is up to 25 tons, we go for B2, and if it is up to 95 tons, we go for B6, and if it is at 112 tons, then we go for B12. This is an everything comes in we assemble everything in the in our workshop, and we just ship it to the facility. This is an example how installation is done at the facility. Everything comes, everything is done, and it's the entire installation. This was in Texas. In 4 days, the entire system is installed. So this is just a video to show how the installation is going on. So everything, it is prefabricated and is transported. Okay, next we go. Okay, so we understood what CAMBI is and how the process works. Now let's talk about the benefits of CAMBI. Now, treatment sludge, treating sludge typically can cost you up to 50% of the operating cost can be from sludge treatment. So if you want to reduce your OPEX, you have to focus on your sludge treatment. And so you need to select a technology, then obviously you will be looking for a technology with the following criteria. First of all, it has to be 100% compliant with any regulation that is there. It has to be low cost, and the solution, the technology must be a sustainable technology, and preferably it should be compact. Whole world is going for compact systems, and land costs in India are extremely high, especially in the cities, and there is hardly any space. So low footprint is very much important. And then you will have in the cities all these wastewater treatment plants. There will be buildings around it, so you want to make sure that there is no odor. There are lot of lawsuits in the Western countries because of this odor. So this is probably, I would probably rank it number one, or number two. It has to be compliant with regulation, then it should not have odor. And preferably it should promote circular economy, so we can produce a sludge which we can recycle and reduce. And today's trend is reduction of carbon footprint, which is very much required to to protect our planet. Okay, so now we have a sludge, and we are subjecting it to 160 degrees centigrade at 6 bar pressure. Now, because of that, as I said, there will be 3 things that will happen. One is it basically sterilizes the sludge. Remember, I told you that sludge is sterilized, anything is sterilized at 122 degrees centigrade, and we are doing it at 160 degrees centigrade. So definitely, yeah, it sterilizes the sludge. It produces a class A product, means pathogen-free product, and it's of very high quality, which can be used as a fertilizer or soil amendment or conditioner. And there is another problem is, many of the other technologies which we will discuss have a problem with pathogen reactivation, means you kill the pathogens, but the pathogens come back. But in our case, it never comes back because everybody has been roasted and pressure that pressure cooker, so all the bacteria and all are gone for good. And we will discuss that in a little more detail. It properties and rheological properties changes, like one is it reduces the sludge viscosity by 50 to 70%, and because of that we can mix the sludge. In digester we cannot we cannot feed digesters with higher solids. Maximum we can feed is 4 to 6%. Beyond that we cannot feed because mixing in the sludge digester becomes a big problem. The higher the solids, the higher is the viscosity. Now and so what happens is, if you put in a THP, then your viscosity is reduced by 50 to 70%. Means you can feed digesters with higher solids, and you can we generally feed around 10 to 12% solids instead of 4 to 6%. As a result, our digester volume is we can load it 2 to 3 times, and we have a reduction in digester volume by 60 to 70%. So that saves you cost, because if you were requiring 9 digesters, now you will be only requiring only 3 digesters. So you save on the cost there. And obviously, as I said before, instead it increases the biodegradability. It's like, instead of apple, you're putting in apple juice to the digester. And so what happens is, when you put in the food that you're feeding to the digester, is very, very degradable. As a result, the volatile destruction, means the biodegradable portion of the sludge is increased. Destruction of that is increased by 20 to 50%. Because of that, you will have higher biogas production by 20 to 50%, because you are destroying more volatile solids. So equivalent amount of biogas will be generated, because you are getting rid of the volatile solids more. Your volume of sludge generation will be less, and because you are getting rid of more volatile solids, and also, like I said, EPS contains 1:4 molecule of water, and you're destroying that in your THP. So the water is no longer held to the sludge molecules, and as a result, you will have high dewaterability. So same equipment which was doing 18 to 20% solid can now do 32 or 33% solid. And of course, lower digester SRT will reduce the digester volume. So viscosity, just to I was talking about, it reduces the viscosity, and you can see this is before the THP. You can see 16.5%, and after THP, it's like a liquid. Same sludge, 14% solids. It's like a normal sludge. And here's it.
Sludge-free that can be, which is primary surface activated sludge, as opposed can be sludge at 10.5% dry solids. This is sludge from digest number 1, which is 6% dry solids.
So that is what it is. So then, what are the benefits? Benefits are of using THP. You get 100% compliance with your regulation. You have a circular economy, because you are producing a sludge that can be reused as a fertilizer, and you are also generating more. Biogas by 20 to 50%. Your capex is reduced because you're saving on your digester volume, and opex is reduced by 50% because you are generating more biogas and generating less sludge, and also your digester volume is reduced. So you have reduced digester mixing requirement, and because sludge is more dewaterable, so your transportation cost is reduced because the percentage solids in your dewatered sludge goes up from 18 to 20% to 32 to 33%. So the volume of sludge to be hauled is reduced. It has the lowest life cycle cost, and you will get a payback period of 5 to 10 years. Means after 10 years in your sewage treatment plant, you will be running a plant, and getting a much better product, which you can actually sell to generate revenue. But your operating cost is also reduced by 50%. So that's a very, very win-win situation. No odor, that is another big thing. The odor is practically zero, or if it is there, it is like after rain you get that smell of soil, that type of smell. So it is very much agreeable. So people in Washington DC, people are very much pleased about installing this technology. The sludge that you get, you can generate revenue out of it, and by selling the sludge as a fertilizer, you will have reduced footprint. As I've said, your digester volume is reduced, and the lowest carbon footprint the process generates. This is performance of 7 THP plants in UK by Thames Water. You can see the volatile solids increased by 34%, gas 34%. All this digester volume is reduced by 70%, and dewaterability is 50%. So conventional was during the time, before the THP was put in, it was only with digester, and when they put in a THP, these were the values they got, and these are the percent differences compared to the conventional system. This is in plant in Beijing. You can see gas production has increased by 40% after they installed it. Before it was only digester, now it is THP plus digester. And methane production has also increased. The volatile solids has also increased. So it is in line with what we saw in the previous slide in UK. This is another plant. Before THP, they used to produce 20,000 tons per year at 20 to 22% sludge. Now, after installing the same system, is producing now 10,000 tons per year of Cambi cake at 30 to 33%, and there is practically no odor or low odor, and it does not have any pathogens. This is a plant in Poland, and you can see the picture, the difference in the quality of the sludge. Cambi contributes actively to circular economy. It produces high quality cake that, like we said, it produces fertilizer. It has no odor. It used for agriculture. It produces energy, increase in energy, lower carbon footprint, and optimization of the assets. Now you can see Cambi cake is a soil amendment product or a fertilizer or soil conditioner, whatever you want to call. This is the picture of whole world showing the quality of land. You'll see the red ones are the degraded ones. And you see there are a lot of our land in India is actually very, very deficient in carbon, nitrogen, and phosphorus, and sludge is the natural resource. And the reason for that is we have been using fertilizer which are mainly inorganic, and urea constitutes about 50% of that. So I'm sorry, 70% of that. So the urea, so all these inorganics are degrading our soil. And if there is, so this needs to be supplemented with carbon, and sludge is a product from sewage treatment plant where people were finding ways how to get rid of it. So now you have a product which you can sell. Say municipalities, they can use this sludge, and every year municipality spends hundreds of crores buying fertilizer for the upkeep of your gardens and playgrounds, roads within the city itself. Now they don't have to. They can save those money and can use it, and that is very much required. And Government of India is giving a lot of pressure, is encouraging to change over from inorganic fertilizer to organic fertilizer, and sludge is a very good option for that. Okay, next one. Here is DC water. You can see the difference. This is without the sludge, and this is after they applied the sludge. So you see the difference in the quality of the land here. It is so barren. It looks so barren, and it is so green and lushy green. It's so nice. This is a company that Washington DC has uses for selling of their sludge to farmers. It's called Bloom, and you can go to bloomsoil.com to get more information about that facility. It's practically done by almost all utilities that have used our product, and this is one of the workers in operators of DC Water, and he uses this Bloom product in his home. We got it from one of the articles where he wrote this, and you can see it is sold in retail shops like here. You have similar to Home Depot and all, where they are packed in bags and then sold to the people come and buy it. Odor complaints are a headache for many utilities, and everybody know nobody wants to basically stay in a place where there is a lot of odor. So our system, THP, generates very, very low odor, and so that is a big thing. And carbon footprint is another big thing that everybody is looking for. So we have to encourage technologies that reduces carbon footprint, and Cambi is the leader, of probably #1 in this field for carbon footprint. These are other technologies. This is called TPAD, pasteurization and drying. These are also good technologies, but these two technologies have a potential for regrowth. Regrowth means they meet class A, but after they store the sludge in few hours or during dewatering dewatering time after the digester, the pathogens again come back. There are a lot of facilities suffering from this, and they have to upgrade their system. So this too becomes a little risky in achieving. There are about 60% or so in that article there. In the US, people have done surveyed all the facilities, and they have found that about a certain percentage, I think it's about 60% or so of these facilities of TPAD and pasteurization are not meeting class A. Remember, you have to meet the class A requirement at the point of use, means where you, after the STP, you will be taking the sludge to a land where you are going to apply it. So it has to meet at that point. And during this storage and dewatering and transportation, the bacteria, the pathogens actually grow back. You don't see such issues with drying, and absolutely not with Cambi. But only problem with drying is, it's a very, very electric. It requires a lot of power and energy. Its operating costs are huge, and maintenance costs drastically rises about after 5-6 years. And many facilities are switching over to THP from drying, and we'll discuss that. And these are all the advantages. You can see, area requirement is very low for THP, so it's a no-brainer. That we are the market leader, or THP is a market leader, and Cambi is covers 80% of the THP market. And you can see the digester volume is less, biogas production is high, volatile solids is high. So it's a very good technology to follow. This is the regrowth thing I was talking about. You see, this is the After pasteurization is also similar thing done. It is done at 70 degrees centigrade. So we do at 160, at 70 degrees centigrade. They do it. So they put it before the digester, and after the digester effluent, they meet the class A limit. But if they then after the digester, when it goes into this dewatering unit, then there is a sudden spike in the bacteria counts and pathogen counts. And within 24-hour storage, it even crosses the 2 lakh limit. So this is what we call a certain regrowth, reactivate and regrowth phenomena. And you can see this is practically same for most technologies, like there are EEH hydrolysis, enzymatic hydrolysis process, and they suffer the same thing, except for CAMBI. You can see CAMBI is maintaining that. So even after 5 days, you come and check, it is still there. This is another study done by WRF. These are all independent studies done by different people. We are just presenting here. Because there is a lot of people doing research on THP, because this is turned out to be the game changer in the field, and which is rightfully so. The benefits are enormous. And so you can see THP, there is hardly any odor issues. But in other processes, you can see there is a lot of odor issues. Footprint, this is thermal drying. This is the digester. You have 12 digesters, and this is the drying space. So this is for one of the plants we were doing, and this is for drying. You see 12 digesters you will require. But with CAMBI, if you put in, you save on the drying space definitely, and this is just a small space. And instead of 12, now you require only 4 digesters, because CAMBI cuts the digester size by 60 to 70%. It reduces it. So you save a lot of space, and this is a big thing, particularly in cities like Mumbai and big cities, any big cities, Mumbai, Delhi, Bangalore. This becomes a big issue. So this is one of the places where the client was initially using drying, and then they got fed up with drying because there were a lot of maintenance issues, species, and then they got rid of the drying, and they built the CAMBI THP there. And you can see it's such a small space it requires, and because CAMBI THP is there, it requires only 3 digesters. If that is the big thing. This is the OPEX comparison on 100 tons per day. If you can see, if you have pasteurization and drying, these are the 2 things that are compared with, compared to THP. The cost is about 200 crores over 15 years extra for pasteurization, and 250 crores if you go for dry. This includes capex and opex, and so this is the life cycle excess. This includes this is the opex. So annual cost is about 200 crores and 250 crores. Okay. I will have to rush because not much time left, I guess. I'll talk about anaerobic co-digestion. This anaerobic co-digestion, we will discuss what is it and how does thermal hydrolysis brings in beneficial uses, and how does it integrate into the system, and what are the case studies and what are the conclusions. As you know, anaerobic digestion is collection of process by which you use microorganisms in the absence of oxygen to degrade an organic product. It can be sludge or it can be organics, and by that you generate a lot of energy in form of biogas. And you also stabilize, which we call stabilize, means you took out the volatile solids. If you would not have done anaerobic digestion, then the volatile solids, if you put it on land, then there it will be degrading and generating methane in the open land. And by doing that in the digester, you basically what we call stabilized the sludge. What is co-digestion? Where you have two different substrates. One could be sludge, another can be food waste. You have a mixture, can be two or more. Okay, it helps in certain areas. One feedstock might have certain restrictions, which the other feedstock can supply. And so that's why co-digestion is very important. Okay, this is a slide methane yield for different types of substrates. This is a typical methane yield we can use. Carbohydrates, proteins, fats, and plant biomass. And this is a percentage of biogas in terms of different feed. It shows you. You can see primary sludge in the sewage treatment plant is here. You'll get around 63-64% methane, and how much biogas is generated, and this is the percentage of methane in there. So depending on the sludge, you can choose from this graph what will be the biogas generated and how much will be the methane from that. So what a typical substrate for co-digestion? It's sewage sludge, septic waste, bio-waste, food waste, manure, and biomass. There you can put in other things also, but we need to try it out. As I said, why we do for co-digestion? Because there are certain environmental problems, maybe due to pollution. The characteristics of the organics may complement each other. There are technical solutions for that, and there might be some synergies. And you want to balance the carbon, nitrogen things. There are a lot of things that goes in there, and one last thing will always be a carbon footprint or less greenhouse gas generation. So what does THP bring in value for co-digestion? It's the same as we have discussed before. The benefits remains the same. It stabilizes, it reduces the water content, it kills the pathogens, it increases the biogas production, and it enables using of resources. This is a picture. You can see, this manure plus bio-waste plus sludge. You can do it. You do Cambi co-digestion plant, and you get different types of products: biogas, energy, biosolids, and the liquid, which you can later use for recovery, like phosphorus and all. Or you can use it as liquid nitrogen also. It has a very high nitrogen value. As same as before, it has no pathogens. It is class A fertilizer. The sludge that is produced, bad odor, easy to handle, and biosolids about 30 to 40% dry solids. This is you can be marketed as soil improvers and fertilizers. We have discussed it. It's the same thing. We have one sister company, Horst. It's now renamed as a new company. They basically take sludge from Norway, and then they export it to Vietnam. It's a multi-million-dollar company. So you'll have waste coming in, you dewater it, you do thermal hydrolysis, digestion is the same thing. It typically, 1 meter cube of biofertilizer will contain about 8 to 10 kg of nitrogen and 1.2 to 1.3 kg of phosphorus, negligible odor. So these are the things. We have several plants, where they use this biomethane, and in Europe, we have it. In Korea, we have it, where they used to run buses. These are 7 places, all over the world, where we have digestion facility. We have built these plants in Europe, in China, South Korea. These are the list of plants. This is in Oslo. This is another plant, just showing you the pictures. This is in China. So CAMBI THP is we can conclude that it is a very good technology for co-digestion, and we already have demonstrated plants. It increases biogas, produces biofertilizer, and reduces greenhouse gas, same as what we discussed as under benefits, and it can be available for various feedstocks. Another concept we want to discuss is the sludge center. Sludge center means in a city, instead of having it at one sewage treatment plant, it can take in sludge from other sewage treatment plants or other facilities. So, so you have the sludge center maybe at one of the sewage treatment plants, or it can be decentralized. So one is one site, or another is decentralized, means you have a separate area for sludge center. We have several references for sludge centers in Europe and China, and in so in the wastewater treatment plant, it receives sludge from other STPs and process it in that wastewater treatment plant, or it can be a dedicated sludge plant which receives and treats sludge from different external sites. So an on-site will be, you have a wastewater treatment plant that goes in there, and then there will be sludge coming from other places, and then you can generate electricity from here, and you can do it, recover energy from here. And you can see this is another imported sludge. So you have the wastewater plant and the imported sludge comes in, and then it is imported means sludge from outside will come in, and this becomes the on-site one, where at the wastewater treatment plant. Okay. So this is the imported. This is decentralized, means all the sludge that is coming in is from outside. So this is the decentralized one, and it's the same scheme that you have here. So, we supply in a modular form, like I said, 2 reactors, 3 reactors, 4 reactors. You can add on. You can start off with 2 reactors, and after 5 years, you think, okay, I need more thing to do. You just put in 2 more reactors in there, and that's it. You are done. So that is a big advantage of THP modularity. These are some pictures of the on-site sludge centers. These are some of the benefits of sludge centers. It maximizes the existing digestion capacity. Possibly small wastewater treatment plants to achieve high cake quality. And these are just you can read it. These are advantages and disadvantages. We have about 14 plants doing sludge center in different parts of the world. These are the references. So so far we have 60. So far we have 67 plants, and of various capacity. That is equivalent. The amount of sludge we treat is equivalent to 76 million population. We have plants all over the world, particularly in capital and large cities, Beijing, Washington, DC, London, Singapore, all over Dublin, Oslo, Brussels, and many other cities. In South America, our clients has been for most of the leading utilities like Anglian Water, Severn Trent, Thames Water, United Utilities. Suez also has done work with us. Hyas was the first facility where we installed our first plant back in 1995. That's 25 years ago. That's when we started. When nobody was there, we started this concept. We are the pioneers in the field. Veolia also takes plants from us. These are the lists of 67 facilities. These are some of the pictures, DC water. We talked about DC water. This is in Greece, which just treats waste activated sludge. This is in Medina, Ohio, USA. This is Devimule, one of the sludge centers in UK. This is Thames Water. These are our systems. Services, we provide continuous improvement services and life cycle support, plant upgrades. We are always there with you to make sure that your plant operates properly because it's also our reputation there. So our plants operate without any problem. We do a lot of other things. We do training, installation, design, any ramp up, site services, front-end engineering. So to wrap up, we have 3 takeaways. Thermal hydrolysis has many benefits, which we discussed. And Cambi THP is the most trusted partner. And we can also look for option for co-digestion and sludge center wherever possible. With that, I thank you. And if you have any questions, I'll be happy to answer them.
Hello, can you read the question, Sushma?
Yes, ma'am. Sir, Mr. Raghavendra have asked, is it 2 million or 2 lakh fecal coliform count?
It is 2 lakh.
2 lakh. Okay, sir. Thank you. And Ms. Chandrima Roy have asked, how can we recover intermediate products from a digester? Can it be done by adjusting retention times?
Can you repeat the question? What is that?
How can we recover intermediate products from a digester? Can it be done by adjusting retention times?
Yeah, I mean, there is something called two-phase digestion where you can recover, acetic acid. So you do 2-stage. First stage in the digester, you do it for a very low SRT and also at acidic pH, and then you do methanogenesis. So yes, you can generate, and it's a well-established process, 2-phase anaerobic digestion.
Okay, sir. Next, Ms. Madhuri have asked, it is a good technology indeed. Can we avoid the digester if the sludge quality is of class A product, which can be directly used as fertilizer?
No, you need a digester. How can you produce class A? To produce class A, you have to need the digester.
Okay, sir. And Kavita Verma have asked, sir, could you please give an idea about the cost effectiveness of this technology?
Cost, it will vary from facility to facility, because it depends on what kind of sludge, what is the quality of sludge in there. So we will design the system accordingly. So if there is a specific requirement, we can work out the cost, but that is the capital cost. But remember, the life cycle cost is the lowest, and it is the only technology that can has a payback period. No other technology has payback period, because it reduces the operating cost by 50%. So every year, your operating cost is savings of 50% adds on to offset the capital cost. In addition to that, your capital cost is reduced because you are only requiring digester volume, which is about 30 to 40% of a conventional system. So you save on the concrete and the land space and the cost of the digester there too.
Okay, thank you, sir. Mr. Raghavendra have asked, how does this technology compare in pricing with respect to the other technologies, both in terms of capital expense and operating expense?
Yeah, that's the slide I was showing. If you look at it, capital cost, capital cost, net capital cost is comparable, but operating cost is you save 50% of your operating cost by installing THP.
Okay, sir. Again, Mr. Raghavendra is asking, is it possible to introduce co-digestion in existing anaerobic digester system in the sewage treatment plant systems?
Yes. The answer is yes. In fact, we have upgraded a lot of existing plants without touching them. The digester is operating as it is. It comes outside and it's plugged in.
Okay, sir. Mr. Prasad is asking, are there any Cambi plants in India?
No, we are, we will soon be having. So right now, no.
Okay, sir. Mr. Sandeep Kumar is asking, recently the emerging pollutants got the attention of researchers. In municipal sewage sludge, there are number of emerging pollutants like pharmaceutical compounds, cosmetics, heavy metals. As you mentioned, the THP is also capable to fix heavy metals and antibiotics. Can you please explain the mechanism?
No, see, our objective of our treatment is different. What you are talking about, all this emerging economics, is yet to come to India. That is mostly in the developed countries. We just last year got a limitation on sewage treatment plant of BOD, COD, TSS, and all these limits, which developed countries had it like probably 20-25 years ago. So we are just at the first stage, and now they are also looking at all these plastics and pharmaceutical compounds, PFAS, and endocrine disruptors, and antibiotics, and all these things. Looking at their fate. So for our system, we have not specifically looked at the. We have not specifically looked at the fate. We are looking at it, but we need to do studies before we can say that these are being taken care of. Since it is, our feeling is, since it is at 160 degrees centigrade and 6 bar pressure, you are basically taking care of everything. That's a lot of temperature and a lot of pressure. And but still, we will not comment until we get the data done, research study done, and finding out the fate of it.
Thank you, sir. Sir, ma'am, as of now, these are all the questions from the chat box. Ma'am, one more question is there.
Yeah.
Are there any constraints Cambi is facing to establish a plant in India? By Mr. Syog Salinke.
Yes, there are constraints, but there are also encouraging replies. Um, you know, first is educating the people. You know, this is a technology which is changing the world, and obviously, to do something, first you have to educate the people. This is exactly what I'm doing. And I joined this company about a year ago, and I can tell you, in 1 year, we saw a tremendous response. It's beyond expectations. People here are very excited, and they want to do it. And some of the municipalities says, we want this technology. Because you see, at the end of the day, it is a technology, first of all, gives you, which is 100% compliance. And so you can sleep in peace. That's the most important thing in your life you need to do. Don't take too much risk. At least have a good sleep. So that is a very important thing. That 100% compliance. There are other technologies, which have shown, not 100% compliance. Means there are many facilities using those technology has not achieved class A requirement. So that is there. But from the tender point of view, like say in USA, there are municipalities who explicitly says, I want CAMBI THP because I know that is good. But in India, you have to have a tender where you have to allow competition and others come in. So it becomes a little difficult. So those things need to be addressed. But one thing, what people in India tenders do not do is to include the land cost. Once you include the land cost, like in Mumbai, they have included land cost. Now you can imagine the cost of land in Mumbai or Delhi or any big cities. Then our system becomes very economical because we save land. 60 to 70% of the digester space is saved. And land, in my opinion, should be taken into account, because if you want to do apple to apple comparison, suppose like a solar dryer, if you put in, it will take up huge space, but its cost is less. So today's world is going with compact systems, so it's a choice of the client, what they want to do. Should we continue doing what we have been doing for previously, or we want to build a new India with new technologies, new features, and better output and quality.
Ma'am, this is the last question.
Sir, I have a question. So after thermal hydrolysis and then the digestion, aerobic digestion, the water which is coming out of the digester.
Yeah.
So and what might be the characteristics of that? Is there any further treatment is required? So once if you do the THP process, so solubilization of COD occurs. Whether all the COD, BOD, whatever solubilization of COD occurs after the THP process, will that anaerobic digestion is taking care of entire removal of that solubilization of that COD or BOD? Or the output of that anaerobic digestion water further needs any treatment?
Okay, let me answer this in two things. First, think about our conventional system. You have a digester, no THP. In that case, you will be generating what we call the reject water from the digester. Okay, and that will be rich in nitrogen and phosphorus. Okay, now if you put in THP, that nitrogen and phosphorus concentration will increase. Now, in a conventional system, there are two ways to treat the reject water. One is you recycle back to the headworks, and you basically mix with your raw wastewater, which most facilities do. But there is something also called side stream treatment, okay, like the Anamox process or the DMON process. In that, what we do is we remove the nitrogen from because the nitrogen from the reject water in a conventional system without THP will be around 1500, 2000 milligrams per liter. So there are some plants which have put in side stream treatment, such as Demon or Anamox, which reduces nitrogen concentration drastically, maybe by 80%, 90%.
Is the also included in this? No.
No. That is side stream. That's a different technology provider.
Hmm.
So that is one thing. And for our case, it will be same approach as conventional system. You can either send it directly back to the raw wastewater plant, or you can do a side stream treatment. Same thing. Only thing, your nitrogen concentration, because our reactor volume is less, so your concentrations will be higher. So yeah.
Is there any requirement of further optimization in the the area wise, like you have mentioned certain conditions, the pressures and temperature? So is it the same conditions everywhere is suitable for doing that THP process for any
No,
sludge?
yeah, see the one that 160 degrees 6 bar pressure, that is the process requirement.
So is it suitable in any area, like any country or weather conditions or the sludge biomass characteristics? Or so you need to further optimization based on the characteristics of the sludge.
No, it is we don't need any optimization. Those studies are already done in our R&D facility. What we need is basically we design for 160 and 6 bar pressure. That is a standard we use. It can be 165 degree, it can be 6.5 bar pressure. So if you are around that range, that basically the whole purpose of subjecting the sludge to that high pressure and temperature is to do two things. One is sterilization, another is changing the properties and rheology, and of course it also increases the biodegradability. So in an anaerobic digestion we have hydrolysis in the digester.
Yeah.
This hydrolysis is done now outside the digester. So we make it, more, like I said, fruit and fruit juice.
More soluble COD or BOD will happen, and then further biodigestion has to take care of that.
Correct. So your time for hydrolysis is saved in the
Yes.
digester, so that your digester becomes much smaller.
So any further questions in chat box? How some Raghavind, any questions, Sushma?
Yes, ma'am. Yes, ma'am. One question.
Yeah.
Mr. Raghavinder is asking, how does the payback work out with THP and without THP systems? In the sense, with conventional systems without THP.
In conventional system, yeah. See,
How does the payback work with?
Yeah, the payback is with respect to conventional system. So our benchmark is conventional system, and then you put in THP. So you have a net capital cost investment, but your operating cost is reduced. So over the years, that operating cost will pay for your capital cost, extra capital cost. So after a certain period, maybe 7 to 10 years, you will see that you have already paid off the capital, and you are operating the plant and getting a better product at a lower operating cost.
So one more, hydrocarbonization. How do you compare this combi technology with the hydrothermal carbonization?
Hydrothermal carbonization, I'm not very familiar with that, so I won't be able to comment on that.
So any more questions? What
Ma'am, yes, ma'am. One more question. Mr. Pravat Kumar is asking, what is the market value of sludge to bioenergy technology right now?
What is the market value of sludge to that? I won't be able to answer. I mean, what is that market value means? What does he exactly need? Is there a push for doing it, or?
This is not, and this is mostly people are looking at reduce the operational cost of the treatment plant. This question, what is the market value of sludge to bioenergy?
I mean, there is all the big municipalities are going in there, and bioenergy sector as a general thing is government is giving lot of impetus to it, and they want to generate more of alternate energy sources. I think the market is pretty good, and it's going to increase over the years. And I would say in 5 years' time, it will be a huge market, because all the countries, not only India, all the countries are moving away from fossil fuel energy. Uh, so alternate energy will be a big thing, and biomass, energy from biomass will be a big thing. And government incentives, I think, are also there. Just 3 months back, I was reading some article on that. And in the energy sector also, I think electrical companies are required to produce certain percentage of revenue from renewable sources. So the world has to go there. The population is going high up, and we have to balance out. Otherwise, it will be a disaster. We will be living uh, um, a world. We want to live a world which is good for our kids. So it is our responsibility to make sure that uh, everything is done in the right way.
So last.
Okay, sir.
Hmm.
Yes, ma'am. Mr. Raghavendra is asking, is in the current scenario, payback is expected in about 2 to 3 years. Isn't 7 years too long?
See, if you want to convert sludge to energy, extra energy, and to fertilizer, there is no technology which is giving you a payback. It is the only technology that is giving you a payback, and 100% compliance. Okay, so in general, if you want to go up, you have to spend, which is true with other technologies. But in our case, you have to spend, but because of the properties of the sludge are changed, we get a lot of advantages, which reduces its operational cost, and that is why we get a payback. In general, we should not be even thinking of payback, because we are trying to produce a better quality sludge. But because our process, is such that it produces additional advantages, which enables the thing, the municipality to save money and get a payback.
Okay, sir. Last one in the chat section. Mr. Pramod Jadhav is asking, can we use nanomaterials and UV rays treatment for compact sludge treatment?
There are lots of technologies that are being experimented and piloted. Not only these 4 technologies that I showed, there are numerous technologies, and there are lots of work going on. But full scale, until and unless things are done on a full scale and demonstrated well, it is still not applicable. So yes, you can use different types of technologies and different types of techniques, but the goal is fixed, and you have to meet the regulation. So yes, you can go for other technologies, but it has to be demonstrated. Many plants, they were thought like, there are pasteurization plant and TPAT plant, which was also even recommended by EPA, pasteurization as a class A technology. And people went and installed it, and then many plants did not meet class A. So this is because one of the things you have to understand is EPA brought out the regulation in 1993, which is like 27 years ago, and they need to, in my opinion, revisit this, because the regulations were made based on the available information at that time. In 27 years, the world water industry has changed drastically. Lots of information, lots of research has been done. So, those things need to be incorporated, and the regulations need to be updated. New techniques have come up, and this was one of the reasons we found out why pasteurization, there is some issues with pasteurization or regrowth and reputting, regrowth issues, because the technique that was used to find out the microorganisms count had some deficiencies compared to the current one. Because it was thought they were dead. Actually, they were not dead. They were only gone in sleeping mode, so inactivation mode. And when favorable conditions came up, they started growing again and reproducing. So that's the thing,
So now there are no questions for hello. Yeah. So no more questions, I think.
Okay.
Yes, ma'am. No more questions.
So thank you, Dr. Indra Mitra Garu. So it's a very useful lecture, and then the present day it is required in India. So all our sewage treatment plants are discharging their sludge without treatment. So this is very essential. And thank you very much for sharing the information on the Kambi. And then within short notice, you have accepted our invitation. So I thought it is, I came to know about this through L&T, Mr. Ganesh. So then I started, I gave a mail to you within a short notice. Thank you very much. And then, so thank you all the participants for patience, your patience for attending for the last 3 days. And then I thank my students, Dr. Bhagawan, Dr. Kavita, Sushma, and I thank our colleague, Dr. Ravi Verma Garu, for supporting, for organizing this. And then I thank all our other students, Shiva, Kiran, Shankar, and for their for organizing this event and sending mails to participants and then giving replies to them, and everything they have taken care of. I just enjoyed sitting here and then listening these lectures. So thank you very much, sir. It's all the day. So now anyone would like to speak about anything, it's also, well, you are also welcome, the participants from your side. So I think we can end the session. So thank you, sir, once again. Hello.
Thank you.
Thank you.
Thank you, everybody. Thank you, Himabindu. It's
Yes.
your organization has been very, very smooth. It was very smooth.
Yeah,
So,
students did everything. I only conceived the idea. That's all they have done. Run the show.
yeah. No. Actually, we all need to get connected and work on. I personally is a wastewater treatment expert, and I was in the US for 17 years working for CH2M Hill, which is Jacobs now. So we are, so we need to bring in all these technologies, latest technologies to India. Wastewater, I know in and out. I have been doing it for the last 22 years.
Yeah.
So we and in India it is very much required. And now with the new regulation coming up, by NGT has issued a regulation. So you will see a lot of technologies. But I see a different, a total change in the way municipalities work is now not just getting things done. They want to put in the right technology, and they want to put in system that works. Yeah.
Sir, I also request you to take like our, we have an MTech program, MTech Environmental Management, and then PhD students, and then for their projects. So like they can do projects at your, wherever you install or these things.
Sure.
Anything. So now they can do online, maybe, but in future, after certain time, they can do physically, they can come and do that thing also for their project.
Yes.
Yeah. So I look forward for more collaborations and
Sure. I mean, university has always been my weak point. I was almost becoming a professor after my PhD. So I got offers for 2 universities in the US, but then I thought I'll get industrial experience and then come back.
yeah.
So teaching is something I do it. I like it and I like it and I do it passionately.
Okay.
Just the other 2 days I was busy last week teaching a course on wastewater treatment.
Oh.
Yeah.
Mm.
Dr. Himabindu,
That's also for us, so we can think of.
Sure.
Thank you very much.
I think, madam, one speaker wants to share something, Mr. Raghavendra.
Dr. Himabindu, thank you very much. Dr. Ravi Verma, very good session. Dr. Indraji, it was a very good session.
Thank
I
you.
am a water treatment and wastewater treatment professional for the last 30 years. So these sessions have been very good for me
Oh, thank you.
personally too. So it has been very knowledgeable thing and very quite informative things.
Oh, thank you. Thank you, sir. Okay.
I am a postgraduate in chemistry and a graduate in chemical engineering.
Oh,
So having 30 years of experience in both water and wastewater treatment.
oh, very good.
It has been a good time.
Yeah.
You know? It has
Oh.
been good sessions. Thank you for organizing this.
Oh, thank you, sir.
Thank you. Dr. Indraji, it was a very good session.
Yeah.
Thank you.